Okay, so yesterday we did components of vectors, and today we're going to be talking about adding vectors in 2 dimensions. So I'll give you a minute to copy this down and I'll read over it. So like before, we are still adding vectors through the tip to tail method, which means you draw one vector and then you draw the next vector, the tip connected to the tail. But we won't be doing 1 dimension anymore. We'll be doing 2 dimensions. So let's jump right into an example. Okay, what is the total displacement of a person who walks 342 meters north and then turns and travels 178 meters west? One of the things you should always do when you're solving one of these problems is always have a little compass. Never eat shredded wheat. If you want to have it in your head, that's great, but my brain is old. I always put it on my page. I don't want to mix them up. Okay, so you might want to pause the video to copy this down, and I'm just going to go ahead and start solving. So the first thing I want to do is draw a diagram. Yes, I'll be drawing triangles, but my triangles will always have arrows to indicate the direction of my vectors. So my vector diagram is going to use these 2 vectors right here, 342 meters north and then 178 meters west. So I'm going to be going north and then I'm going to be going west. So let's draw that. And when I draw them, I don't need to draw them to scale, but what I will do is I'll draw them maybe in terms of relative length. So this one that I did here is north, 342 meters. And then I'm going to connect the next one and go west. And I'm going to draw this one shorter because it's not as far. It's 178 meters. Now when I draw in my resultant, okay, and I've made sure that these are 90 degrees because they are, one's north and one's west. I start at the beginning and I draw my resultant with the arrow at the end or where I finished. Okay, so there's the side of my triangle, but that's a vector. So from start to finish. And that's very important. Then you always label the theta, okay, at the tail of the vector. So this is the displacement that I'm going to be solving for. So as you're drawing this, think about what type of triangle this is, what sides do you have, and what angle you're looking for. So I'm just going to make a little note there. Always label the angle theta at the tail of the vector. Okay. And you can see this is a right angle triangle, and I have the 2 legs of that. So I'm number 1, I'm going to use Pythagorean theorem, or as I call it, Pythag, to get the magnitude of the vector. Remember, magnitude is the fancy word for the number. And number 2, I'm going to get the angle, and I'm going to use the tangent function because I have the opposite and I have the adjacent side. All right, so let's go ahead and do that. Now, some student might say, well, why can't, after I find the hypotenuse, I can use sine and I can use cos? Yeah, you could, but I always like to use the given information in the question. Okay, so let's get the magnitude over here. So Pythag. Okay, I'm just solving for the magnitude. And so I always need to square root that. So it's 178 squared plus 342 squared. Right, and that's just c squared equals a squared plus b squared. But I'm solving for delta t, so I'm just going to do it all in one step because you guys are pros. I'm going to go ahead and put that in my calculator. Make Should I put in right? Yes. I hit equals, I square root it, hit the answer, and I get 385.54. And that's going to be meters because this was meters squared, this was meters squared, but then I square rooted it. And I'm not going to round that yet. I'll round it when I put the two parts together. I'll put the magnitude and the angle together when I name the vector. Okay, so here tan theta equals opposite over adjacent. This is the opposite. This is the adjacent. And because I want theta, you have to remember we need to get the theta out of the function. So what we're going to do is take the tan inverse of both sides, right? Because whatever we do to one side, we have to do to the other. And opposite is 178. Adjacent is 342. I'm not putting in units here. Does it really matter? Well, to some degree it does, and to some degree it doesn't. They're both meters, so they're going to divide out. If they were different, you would have to have them be the same unit. Okay, but they're both the same, so they will divide out. All right, so tan inverse and tan cancel each other out, and I'm left with the tan inverse of 178 over 342. So make sure your calculator's in degrees. Shift tan, open a bracket, 178 divided by 342, close the bracket. There we go, 27.49. Okay, and that's degrees. And now I'm going to put these two things together and round to the correct number of significant digits. When I look at my question, I was given 3 significant digits, so my final answer can have 3 significant digits. So my final displacement is approximately, okay, I've got 385 here, but there's a 5, so that puts me in the middle. So I'm going to round that to an even value, 386 meters. And now I'm going to get my angle. So I'm going to point north, okay, and then I'm going to rotate west. So I'm going to point north. I'm going to rotate 27.5 degrees towards the west. And that is the most simple 2D, I would say, because both of those vectors are only in one direction. The next example, we're going to do vectors that are in 2 directions. So we'll have to use the idea of components and adding vectors. Okay, so that'll be the next question. I'll pause here and get the next question ready. Okay, so here's the next question. And you might want to pause this to get it after I finish talking. But a plane flies 240 kilometers south and then turns and flies 144 meters north, 35 degrees east. Determine the displacement of the plane. Now, what you might want to do is draw your own picture before you see mine. Okay, and don't forget, I always include this. You have to draw that as part of your solution. I don't give that to you in the question, but I always do this just to keep track of and think about what direction is occurring. Okay, so pause it here, draw your own picture, and then I'm going to talk to you about how to solve this. Okay? All right, so I'm going to go 240 kilometers south and then north 35 degrees east. So let's think about that. I'm going to go south, so I'm going to draw my vector down, and then I need to go northeast. So that's going to be in that direction. So something like that. Let's go ahead and do it. So 200, I'm going to do this in the middle of the page, and you'll see why in a bit. The other thing that I will do when I solve this question is there's 2 different ways of solving this. There's people who are really good with visual and diagrams, and then I also have a method with using a chart. And one thing is keeping yourself organized when you're solving these questions. So if you're a disorganized person, the chart really helps. So north, 35 degrees east. So north 35 degrees east, this is about 45. Again, it doesn't really matter, but I just like to think about what I'm doing. So there's my arrow. I know the next one. So this angle is 35 degrees because it's north 35 degrees towards the east. And that number is 144. And then I'm going to draw in the resultant. So I start at the start and end where I finished. And it's going to look like that. And that's what I'm going to be solving for. Okay. Now, you might think, "Whoa, that looks really complicated." I'm going to draw a bunch of vectors, and I don't want you to copy while I'm drawing them. I want you to really watch and listen to what I'm saying. Okay? Because each of these vectors have components. Okay? This one has a component only in the south, but this one here, okay, has a horizontal component and a vertical component. I'll color code this to see if this hopefully helps you. And it has a vertical component. Okay, and those are 90 degrees to each other. And you might think I'm going to make a mess of this, but just watch. Okay? Then this vector up here also has components. This is the vector I want to find, this displacement vector. Let's find the components of that vector, and maybe you'll see what's going to happen. So I'm going to draw the component of that vector. Okay? And then I'm going to draw the component here. And then you might see what's happening. Okay? For me to find this vector, I need to know its components. Well, its components are made up of the other vectors. So if you notice, the horizontal component, or this green one, is exactly the same as this vector down here. So if I know the horizontal component here, I know the horizontal component of my displacement vector. Do I know that vector? Sure, because I have an angle. Now you might not see it here in this triangle, but you can always do the opposite angle theorem. So here's the 35 degrees. This is also 35 degrees up here. And if you don't like that, this one's 90 degrees here. You could always give the complementary angle. But you do whatever makes sense to you. Okay? So I already know this vector because I know 144 and I know an angle. Therefore, I know an angle and a side. I can solve the whole triangle because it's a 90-degree triangle. So I actually know two angles and a side. All right, what about this vector here? The vertical component. It's not as easy, but take a look. I have a vertical vector here and I have a vertical vector here. Okay, this vector here is 240 minus whatever this component is. And I have to figure out what that is, subtracting whatever number that is. All right, so now if you want to solve all the sides on this diagram, you can. And I can show you how to do that. Okay, this is the opposite side. Okay, to a triangle. If you want, if this is confusing, you can put the 144 right along there. And like I said yesterday, that's 144 sine of 35 degrees. And this side over here is 144 cos of 35 degrees. And that's just using sine and cosine functions, right? Because sine of theta, that's using SOHCAHTOA. That's what we did yesterday. SOHCAHTOA. And then when we're solving for the opposite or the adjacent, which is what I'm always doing when I'm finding components. Remember, I'm always cross-multiplying or multiplying both sides by the hypotenuse. So that's where that comes from. Okay? All right, now that's only part of it, because once you find the components, you need to put those components together and do what I just did on the previous question, right? This question. So essentially, to solve these questions, what you do is you break down the individual vectors into components like I did here, and then you simplify by combining the vertical components and combining the horizontal components. In this one, there's only one horizontal component, okay? And then you're going to have a 90-degree triangle that you solve with Pythag and inverse tan. So I'm going to use my chart way there here to solve this question in case you prefer that. But essentially, you visual people, you might really like this way. And if you're confused, don't worry. Here's the second way. And I didn't fully solve that one yet, because I'm not going to fully solve it both ways. All right, so when I do the diagram, or use this diagram to make a chart, this is the chart method. Okay, what I do is I break everything up into components and I draw the vectors in a chart way. So I have my X, and my X direction is my east/west. This is also known as the horizontal. Okay, and then I have my Y components, which are my north/south, also known as my vertical. All right, so essentially what I'm doing, I'm adding these two vectors. So what I do is I write the first vector here. It's 240 kilometers south, and then I draw myself a little sketch. It's just down. Okay, so what's the east-west, or the horizontal component of that? There's none. It's only south. So 240 kilometers south. All right, so that one is the easy one. The next one, okay, has two dimensions. That is my 144 north, 35 degrees east. So 144 kilometers north, 35 degrees east. So I give myself a little sketch. How do I do that? I draw a little compass. I draw a vector here. This is 35 degrees. Now, I know in this picture, I drew right and then over, but that's just because I didn't want to run into this one over here. So hopefully I don't confuse you. I'll use the same colors though. And I'm going to go up, and then I'm going to go over, because remember, it doesn't matter which way you go first. Okay. So my east-west is green. This is my X right here. Okay, my X component. All right, that is opposite. Okay, so that's going to be 144 kilometers, and it's going to be sine of 35 degrees because it is the opposite side. I'll get out my calculator after and work out those numbers. Okay. And if you didn't know where that came from, I can do more, but I'm just showing the rearrange. Sine of 35 is opposite over hypotenuse. Opposite is the X, and hypotenuse is the 144. So really what I'm doing is rearranging that. I'm multiplying across, so I'm left with X. I'm really just writing the value of X right here, because this whole column are the X components. Okay, so now let's do Y. If I look at Y, and you don't have to color code and all this, I'm just doing this hopefully to make it more understandable for you. So this is the adjacent side. So this is going to be 144 kilometers, and this is going to be cos of 35 degrees. Where did that come from? That came from 35 degrees equals Y over 144, right? Because this is the hypotenuse is 144 kilometers right there. Oops. All right. So now all of that mumbo jumbo. Now I should put in the direction. I didn't put it in. So this right here, the X is to the right. That is east. And this one here is to the north. So now what we do is we actually have one more row. And this is going to be the total component. So what do? Well, I take this one, I add this one, and it equals right here. Okay, so this is where I get my calculator out. I'm really adding 0 plus this 144 sine of 35 degrees. So let's figure out what that is. Make sure you guys can see what I'm doing. Maybe I'll put it over here. Okay, so 144 sine of 35. My calculator's in degrees. I hit equals. It's 82.59. And this is in the east direction. Okay, so I'm just adding up the column. That one was an easy one because that one was 0. There was no value there. So now I'm going to add these two up. This one, I don't have to do anything with it because there is only one component. It's already solved for, but I do need this one right here. So I'll get that value and put it in to calculate it. Okay, so here we go. 144 cos of 35. And it's really easy to mix up cos and sine. So make sure you're always pressing the right one on your calculator. So that number is 117. Get out my... If you want to write it down there, you can. Then you don't have to put it in your calculator again if you hit clear. So that's that value. I'm not going to clear it. I'm going to add my 240 to that, and I get 357. So I'm adding this value, and I get 357.95. And that's going to be, oh, is that right? Ms. Gork's not paying attention to directions, is she? I'm so worried about the calculator and the light and everything. This is in the north. This is in the south. So this is not the value because they're in opposite directions. Okay, so let's think ahead here. 240, 117. Okay, this is going to be negative south because to be able to do the math, I need to have the directions be the same. Okay, so I'm going to throw a negative south out there. And so I'm going to subtract 240 from that. That's why I have the 117. Okay. And so anyway, that is not the answer. 240 minus 117.95. And I get 122.05. And that's going to be in the south. Okay. So now those are my two components, and I forgot to put in my units, but they're both kilometers. I somehow dropped my units there. Okay. Now I do what I did last time. I put those two components together to get my final displacement. So let's see if I can fit this on the same page. I'll go up here. Okay, so I'm putting the components together. Okay, so east and then south. So east, and if you want, I'll color code this again. So east and then south. And then I'm finding my resultant there. And getting my theta at the tail. Okay, so this is 82.59 kilometers. This one's 122.05 kilometers. So I'm going to use Pythagorean theorem to get the magnitude. 82.59 squared plus 122.05 squared. I'm trying to squish it in there. So got my 122 squared plus 82.59 squared. Square root it. I get 147.36. Don't forget your units. I'm not going to round that yet because I don't need to. All right, and now I'm going to get theta. And honestly, it's the same thing every time, people. So I just really go theta equals tan inverse. And I always draw this triangle. I'm arguing with my grade 12s about sketching this. So opposite, adjacent, opposite, adjacent. Now, if you drew the other triangle and you just wanted to go south and then east, you're going to get the complementary angle. We talked about that yesterday. You only need one. Okay, so tan of theta opposite. Make sure I put this in right after I say it's important. Okay, those are both in kilometers. All right, so in shift tan 122.05 divided by 82.59. Make sure I got the numbers right. I hit equals 55.91 degrees. All right, so let's see if I can squish in my final answer here. Approximately. Now, look back, 2 significant figures is what I can have. So 147.36 is going to become approximately 150 kilometers. I'm just going to put the direction down here because I don't have a space. So I'm going to point east, and then I'm going to rotate south. So point east. Okay, I'm going to rotate 56 degrees south. Okay, and there is my final answer right there. All right, so what I'll do too is I'll take a picture of these and put them into the Google Classroom. All right. Okay, so there is the chart method. You can actually do all this work on here and find the components if you don't like the chart method. But the chart is really good for people who are disorganized or who like to be organized. Okay? All right. Bye-bye.